Okay, so here we have a problem. In outer space, a rock of mass 3 kilograms is attached to a long spring and swung at a constant speed in a radius of 9 meters. The spring exerts a constant force of 660 newtons. You have to find two things. One, what is the speed of the rock? And two, what is the stiffness of the spring in its relaxed state, which is 8.7 meters. So let's get down to it. Our given information, as seen above, the mass of the rock is 3 kilograms, the radius is 9 meters, and the magnitude of the force is 660 newtons. So in the first step, we had to find the speed of the rock, and we would use the starting equation of force equals mv squared over r. Now note that there is no change in velocity. Because there is no change in velocity, you would use the perpendicular force, and that equation, the starting equation, the F equals mv squared over r, is the equation you use for the perpendicular force. And from then on, after you have your equation, you can plug in the numbers, and you would get a velocity of 44.5 meters per second. Now for step 2. In step 2, we're trying to find the stiffness of the spring. And in the problem, it gives you that in the relaxed state, the spring is 8.7 meters. So you would use your equation. Force equals the stiffness times S, which you can rewrite as Ks times the radius minus the relaxed length. And from then on, you plug and chug and you get your answer for the stiffness of 2200 newtons per meter. Okay, now in this example, it's going to deal with trig. Trig can be used in many different types of physics problems, and this example will explain a little bit of that. So, a rope is attached to a block. The rope pulls on the block with a force of 270 newtons at an angle of 25 degrees to the horizontal. You have to find two things, the x component of the force and the y component of the force. So your given information, excuse me, you have the force, which is in this case tension on the rope, which is 270 newtons, and angle theta of 25 degrees. And here is a diagram of what this should look like and what this question illustrates. Now for this problem, you're going to need to know some basic trig. And here are the basic trigonomic equations. So, for part 1, it wants you to find the x component of the force. Now if you look back to your diagram, I labeled the x in red. Go to your basic trig functions, and you'll see that cosine is the adjacent over the hypotenuse. Check your diagram and go back. Plug your values in to get 245 newtons. And you'll go through the same process for the y component of the force. You'll look at your diagram, look at your triangle, determine what you have and what you need. And in this instance, we have sine of y over h. And through further manipulation, you end up with 114 newtons in the y direction.